Hi, and in today's video I'm going to show you how to derive the equation for maximum height of an object in projectile motion. So you can see on the top left that the maximum height is equal to v squared by sine squared theta over 2g. Now on our graph on the right side we see that the maximum height is over here at the center point. This is the maximum height. And now, what is true when the object is at this position? Well, at this position, the velocity in the y direction is equal to 0 meters per second. We're going to use this fact to prove our equation. Now, to actually come up with this proof, we'll use two of Newton's equations. So the first is S is equal to ut plus a half at squared. Now applying this to this situation, we have that y, or the height in the y direction, is equal to the initial velocity in the y direction by time minus a half gt squared. Now why the minus sign? Well, g actually acts in the negative direction or downwards, and it's 9.8 meters per second squared, hence the negative sign. So we'll call this equation 1. Our second equation is, or second one of Newton's equation is v is equal to u plus at. Now applying this to projectile motion, we have that the velocity in the y direction is equal to the initial velocity in the y direction minus gt. Now we see here that vy is actually equal to 0. So this means we can rewrite this. Let's call this equation 2. We can rewrite equation 2 as 0 is equal to uy minus gt. Now let's try to make t disappear. So to do this, we make t the substitute formula in equation 2. So we have gt is equal to initial velocity in the y direction, and now from this we get that t is equal to the initial velocity in the y direction over g, and we'll call this equation 3. Now let's sub in equation 3 in equation 2. So sub 3 in, 1. So now let's write equation 1 down. So y is equal to u in the y direction, or initial velocity in the y direction, by time minus a half gt squared. Now we'll sub in t is equal to uy over g. So let's sub it in. So y is equal to uy, then we sub in uy over g minus a half g, then uy over g all squared. Now let's simplify this a bit. So y is equal to uy squared, or initial velocity squared, over g minus a half by g. So if you look carefully here, actually let's do this in an extra step just to make it a bit simple to understand. Uy squared over g squared, and here we see that the g's cancel, so this actually becomes y is equal to uy squared over g minus 1 over 2 uy squared over g. And we see that uy squared over g is common, so we can just factor it out. and we get y is equal to uy. Let's do this on a new page. So I'll make it simple as well. Uy squared over g minus a half uy squared over g. And by basic subtraction, we have that this is equal to a half uy squared over g. And now I want you to recall that uy, or the velocity in the y direction, is actually equal to u sine theta, or it can be v sine theta. It really depends. It doesn't really matter actually. So this is equal to v squared sine squared theta over 2g, or u squared sine squared theta over 2g. And yep, we have proved our equation. So thanks for watching, and I hope you understand and it was simple enough. And yeah, that's it for now.